So hi guys, my name is Bach Hadry. I work here at LinkedIn. I am a part of the SNA team, that's Search, Network, and Analytics. I'm actually part of the analytics part of that, which is basically what the team does is they build products that are derived from the massive amounts of data that LinkedIn.com collects on its users. So you may be familiar with some of these if you use LinkedIn. Products like People You May Know, Profile Stats, or Who Viewed My Profile, Career Explorer. These are all products that are built off of LinkedIn's data. And one of the things that we really would like to do is be able to create new products and iterate rapidly. So LinkedIn's web application framework is currently a very Java-centric, Java framework, Spring MVC heavy code base. And we found that it's a little bit harder to iterate rapidly when you have to create 10 classes and edit 15 XML files and that kind of thing to get a web application up and running in an environment. And that's not just LinkedIn. That's any site web app that uses Java to do web application development. So why are we trying to use JRuby? So code speaks louder than words. We wanted to be able to iterate rapidly. We wanted to be able to reuse a lot of our existing Java infrastructure that we have, libraries to authenticate, libraries to log, libraries to track. That was all there in Java, and we didn't want to have to recreate it. This is very similar to Noah, to what you guys were doing at Onsite. The JVM, which is an awesome piece of software. It has, tons of monitoring. It's heavily tuned. The garbage collection is great. The garbage collection is tunable. All that stuff about the JVM is really great. We want to be able to hire Ruby people. Ruby is a language that's used for a lot of web application development, and I think Ruby and web application development sort of go hand in hand. And so we sort of expand our talent pool that way. And we want to have fun coding. I think it's just a lot of fun coding in Ruby. So we wanted to capitalize on all of that. So some background on our site. Let's bring up profile of a guy named Matt Hayes, who's my partner in crime in getting a lot of this JRuby infrastructure up and running. So consumer web app like LinkedIn, you have to authenticate to access pages. So here in this case, I'm authenticating. What's my password? Oh yeah. And I get redirected to Matt's profile page. When you look at this profile page, there's a ton of data that's actually being collected. There's information about Matt. There is his reading list. There is his activity, his experience, his profile, his connections, groups, education, all this stuff. All this data is basically scattered around LinkedIn's backend. There's databases, there's services, there's key value stores, there's all kinds of things. There's all kinds of service calls going on to aggregate this data. Not only that, there is this thing, I don't know if this is web parlance, I think it is, it's called a Chrome. It's basically the thing that decorates every LinkedIn page. So we have this header that has, home, profile, all this stuff that follows you everywhere you go on LinkedIn and gives you context on your LinkedIn site and the ability for you to access your information on LinkedIn. That Chrome is available everywhere. That Chrome is implemented in JSP in our Java web framework. So we wanted to be able to reuse that Chrome when we do web app implementation in JRuby. We also wanted to be able to get all this data. So, site speed is really important here at LinkedIn. And when you're doing so many back-end service calls, you want to try and be as fast as possible. So LinkedIn has basically created a asynchronous parallel service I/O layer. So when the web app retrieves all this data, the page doesn't take as long to load as the sum of all of the service calls. It takes as long to load as the slowest service call that's made. So that requires sort of an asynchronous parallel kind of RPC layer. And I'll go into more of that later as to how we implemented that in our JRuby web application framework. So that's a little background on the kinds of things that the challenges that we had to solve when translating a LinkedIn web application to JRuby. This is like a 5-mile high view of the LinkedIn architecture. We've got the front end, which is basically just a bunch of individual web applications running on different machines in different Tomcat instances. Each of these web applications depends on a variety of backend services. And again, these service calls are done in a parallel asynchronous fashion. So we needed to be able to implement that. So how do we take JRuby and plug that into an existing full-featured custom Java web application framework that's using Spring MVC and a custom JSP compiler that's deployed to Tomcat? So it's kind of a challenge to get the round peg to fit in that square hole. And I wanted to show you guys like exactly what our web application architecture looks like as far as JRuby is concerned. So the request comes in to our data center. It hits a machine that's running Tomcat, and Tomcat understands the servlet API. All of our production web apps are deployed as wars on these Tomcat machines. So the request comes in to Tomcat. Then it hits a bunch of custom LinkedIn filters and a custom LinkedIn servlet. The servlet is a Spring MVC servlet. And this code does very important stuff like security, verifying you are who you are, authentication, making sure that you have the appropriate credentials to access the data that you're looking at, tracking page views to see what our users are looking at, and bootstrapping of our service layer. So how do we make service calls? What are the classes we use? What are the objects that we need? Then the request hits this third-party open source library that we're using called SiteMesh. SiteMesh it's a really neat piece of software that what it does is it takes HTML and it breaks it, it turns basically an HTML string into an object, and on that object you can access the header, the body, and the footer. And then what you can do is merge the head of that HTML content with another head. So this was the key for us to be able to get, control over our Chrome. So the Chrome is what loads our JavaScript, it's what loads our CSS, it's what sets the title. It's basically the head, the HTML head of the page. So we need to be able to add JavaScript, we need to be able to add CSS, we need to be able to change the title of the page. And we used SiteMesh to do this. From SiteMesh, we go into a piece of software called JRuby Rack. So if anybody's heard of Rack, it's sort of like, I'd say, an analogy to Java Servlet API. It's sort of a unified Ruby web application framework. It specifies an interface. And basically that interface, like where, the Java Servlet API has service, post, get, delete, all that stuff that the HTTP servlet implements. Rack basically has an interface that's called call, which gets a request and returns a response. So what JRuby Rack does is it it exposes a servlet API, but then it accepts basically a Rack application, a Ruby Rack application, and can call into that Ruby Rack web application. So what we did is we actually had to create a customized LinkedIn Rack servlet because the out-of-the-box Rack servlet that comes with JRuby Rack didn't exactly meet our needs, so we overwrote it so that we could do some special case error handling. So like what happens when our underlying code throws an exception? We want to be able to forward to a 404 page, a 500 page, back to the home page, back to the login page, depending on the use case or what the exception is. And so the JRuby Rack has this thing called Rack Servlet. We have our own LinkedIn Rack Servlet, and the way we transfer control from Rack from our LinkedIn servlet, that second box, to JRuby Rack is via name dispatch. So the servlet API allows you to reference servlets that you declare in your web.xml and allows you to redirect to those servlets. And there's some finicky stuff between whether you use a dispatcher and you forward to a servlet, or whether you use a name dispatcher. So we transfer control via a name dispatcher. This allows us to do things like redirect from our JRuby code. It allows us to send set response statuses in our JRuby code. So this is an important realization that we had when implementing this. Then the JRuby Rack actually calls into Sinatra. So I get the feeling that this is a pretty Rails-friendly crowd. How many of you guys know or have used Sinatra before? Okay, so a lot of you. But for those of you who haven't, Sinatra is a very, very lightweight Ruby web application framework. I'll show you a little bit of Sinatra code in a bit. But we had to do some custom stuff even within Sinatra. We created a custom service DSL that allows us to make asynchronous backend calls. And our backend calls are, they're parallel, they're asynchronous, and they're based on Google's protobufs. They're not REST, they're not, database calls or anything like that. And then we also created some custom Sinatra extensions that allow us to do a lot of the functionality that our regular Java web applications do, such as, URL generation, which means linking to other parts of the LinkedIn.com site, such as a profile page or an email or something like that. Logging, authentication, formatting resources, things like, you have a geolocation. How do you represent that as a string to the user? You don't want to say, this location is 94025. You want to say Menlo Park, California. So we wanted to be able to do all of this within a JRuby web app. And here's what Sinatra looks like. So a very simple Sinatra app would be, get hello. Hello is the route, the actual request path. And you can use ERB just like in Rails, and you pass in a template, in this case called layout. And then you can get out, what that returns is basically some HTML. And then eventually that makes its way out of our stack. It goes through SiteMesh. SiteMesh takes the HTML response, breaks it into an object, applies the Chrome to it, and then you have a response. So let's see some of this in action. So here is a LinkedIn JRuby web application. It's 7 lines of code. And what this gets you is this. So you see the LinkedIn Chrome, you see the content that you generated from the Sinatra route, you see the footer, all those links that are required. One of the really awesome things about using Ruby, and one of the really nice things about using Sinatra, is dynamic class reloading. So let's say I decided that this page requires the user to authenticate. I simply add one of our Sinatra extensions, and I reload the page. This now forces me to authenticate the control route. So what this shows you is an example of how we manage to control our Chrome. So we're able to basically set a CSS style in the header, and we're able to specify meta tags that actually say what kind of Chrome theme we want to apply. So our service layer DSL. So the authenticate call forces the user to redirect back to the login page, and then we'll authenticate them and then redirect them back to the route that they were originally at. Here is how we implemented our service layer. So what you see here is the declaration of some resources that we want to get data from. There is a what we call a URI, sort of in the RESTful sense, and a version on that URI. And we specify that we want to get data from that resource. In this case, we're getting data from two resources. One is a profile resource. The other is a member connections resource. That will return us 2 bits of data, profile data and connection data. So the key to the actual parallel asynchronous part of this is this assemble block. So what this assemble block does is it allows those 2 GET calls to be done in parallel. So what we try to do here is, there's this sort of like difficulty when you're working with an asynchronous RPC framework where the code that you see isn't necessarily the order in which it's executed because it's asynchronous. We also have a pretty sophisticated framework where it knows about dependencies and it can resolve dependencies. So you can specify that one piece of data depends on the result of another. And then you basically create this big dependency tree, and this framework will understand which data needs to be fetched, what data can be fetched in parallel, and then in the end assembles all that data together and returns it to the user. In Java land, this is kind of difficult. When you look at the code, it's kind of difficult to understand. But because Ruby is so expressive and it allows us to create these DSLs, we basically were able to create a little simple language that specifies what data we want to get and sort of shows it in an imperative way, but it's actually happening in a declarative way. Though when the block returns, you can be guaranteed that you actually have this data. And then you can simply refer to the data as when it's returned and show the data that way. So we were able to not only use our Chrome, use our authentication, take advantage of our backend of our sort of asynchronous I/O layer. We were able to do all of that in JRuby, and I think it's gonna hopefully help us make our web application development faster and easier. There are some, there are some outstanding issues. Like we want to test the performance of this when we fully ramp up some of these JRuby web applications in production, and see how it all goes. But right now it looks really promising. So here's an example. Not sure if you guys have heard of a new product that we've launched. It's in beta right now. It's by invite only. It's called Signal. And what it does is it marries LinkedIn status updates with tweets from people that are in your LinkedIn network. And then it allows you to refine that stream so that you can actually, try and get relevant data from this overload of information. So for example, here, I am looking at status updates and tweets from people who are in my first level of connections, from people who are in the staffing and recruiting industry and who work at LinkedIn. So, and it's very dynamic. So I can say, no, you know what, I'm interested in seeing tweets and status updates from people in computer software, but not in staffing and recruiting. So this allows me to see that. And this is all done in JRuby. So that's an example of a LinkedIn product in action. Thanks, guys. But hopefully you'll be seeing some more JRuby apps on productionlinkedin.com soon.